Hello, I'm here with John.
Aloha.
Here is our update for you guys, as promised. We're going to talk about what we just went over in our little mini update here. We're going to talk about our signals today on a volcano, whatever recent imagery we have, and then we're going to go into some of the theory, the big picture stuff. So, not sure if anyone tuned in time to hear any of that little intro, but so let me say it again. Hey, hi guys, thanks for joining us. We are here in Volcano at the golf course subdivision, myself and John.
Aloha.
And we have a couple of things in store for you guys today. We're going to talk a little bit about what's happening with the volcano signals today. Tilt signals or earthquakes. We'll look at the little imagery we have. And then we have dial up for you guys. Pull out the whiteboard with some.
The whiteboard.
Yeah, I know you guys can't see it with the glare right now, but when it comes time, we'll go into big picture stuff as far as how the volcano might actually work. I'm going to tie this into the deep earthquakes. I see Nathan is joining us, so good to see you, Nathan. We'll hopefully answer some deep Bahala earthquake questions for you today in a little while. But for now, to start, maybe we'll start with the tilt signal, perhaps?
Yeah. Tilt.
So let's start with the tilt signal, you guys. Let me turn the camera around here. And here we are on the Hawaii Tracker tilt page, and we'll look at the plots that we have lined up here today. So in the last day, we have had a big drop in the summit signal right here and a big spike in a pool signal. However, it's been pouring rain here today in the upper Puna region at least. I'm not sure about lower Puna as much, but at my place by Fern Forest, not that far from Pu'o'o, we might have had something like 4 inches of rain today already. Not quite as much up here at the summit, but there's also been some at the summit as well. So Nathan, we're going to get to those Bahala earthquakes in a little while. Just hang on here. We're going to answer probably more than you wanted to know, hopefully. So, but looking at the tilt signal still, we can kind of see we still have our everyday diurnal pattern, which is kind of broken today. You know, I wouldn't expect to see as much of that today, given that we have so much rain and cloud cover and all of that. So, looking at the Wekahuna signal, we actually don't see that much of a change. It could be that this is actually slightly off of the real heavy rainfall zone. You know, we don't know exactly. But it has been definitely raining in the area, maybe not quite as much, maybe not enough to flood those things. Looking at the signal a little farther down, we see the beginnings of a drop over here on the radial tilt. And maybe one thing I haven't explained before for you guys, maybe I can just do a little quick thing about the tilt here. These plots that have two lines as radial and tangential, all it really means is they're all pointing in different directions, right? So like the blue line is pointing in a direction of 60 degrees east and north, and the green line is pointing at 150, yeah. So they're 90 degrees apart no matter what. So they're basically two axes right out of the ground, and you know, depending if the thing tilts more that way or more this way or some combination of both, that's what the tilt is actually measuring. So you know, which one you actually look at kind of depends which way the thing is swelling from or the ground is changing from. Normally we look at the radial because we assume that they point the radial direction in a direction of biggest interest. So if you're like by the rift zone, you point the radial thing directly towards or away to the rift zone, so you kind of see the rift zone signal inflating and deflating. But the other signal will detect the changes along the rift zone, for example. So they're both useful in their own way. And normally when we see the single tilt, they actually take the square root of the sum of the square of these, if you like matter. So you guys basically take a combination of these two lines to produce a single line like we see farther up here in this kind of signal, right? So some of the nuts and bolts there doesn't matter for most of you guys, but basically, you know, the short part of it is you want to look at, you know, most of the time you look at the radial signal, which is usually the blue line, as a main signal here. And you guys can kind of see that, you know, this was still debated among us, you know, what the event actually was, whether it was mostly rain-induced or whether it was a real true deflation of magma from the summit going into the rift zone or elsewhere. You know, we don't really know. And we've still waiting for official word from someone who knows more than us, since we don't know everything. And Otherwise, we've had a long trend, basically, of deflation at the summit until the last couple of days, where it's had a slight signal of maybe starting to increase before right here at the right end of the plot. It's starting to drop down again, we think, from this rain signal. We're going to probably see a rain signal, maybe not as big as this, but maybe some similar kind of shape as that, kind of over here on the right side. And if you want to jump in at any point, John, feel free. Otherwise, I'll just kind of keep going and say that these patterns look like they were repeating in most of the stations. So here is the escape road. See that similar kind of drop. We see something starting over here as well. You can see that, one of the signals, the radio signal in this case is pointing straight north, right? And this one's actually showing the east-west is showing more signal in this case. We have to look at the map exactly, but that, that's not unexpected, seeing as the rift zone kind of goes actually west of the escape road station, from what I remember. This may actually be the relevant signal in this particular diagram. So, but you see that, patterns are kind of, when this one went down, this one rose, and we hope to see a similar kind of pattern over here as well. So we'll see if that stays the same or what's going on there as well, as we see more information. Mauna Ulu is showing a much more oscillation in the day-to-day variations, but looking at, for example, well, first we can look at maybe the midpoint of this oscillation kind of going down, and we kind of lose the oscillation because we don't see that day signal. Maybe it was too rainy during those days to really see that. So we might have a similar kind of thing where it's kind of going down and not quite as big a bumps happening right over here. We'll have to wait and see, but that's what I would expect. Corresponding with the green line kind of rising up, starting to do that over here as well. So those are, at this point, support for everything we're seeing on these plots being rain-induced, although I do believe there is a magma signal embedded in here somewhere. It's kind of hard to separate it from everything else going on. It's kind of obscured from everything else that we can see. So at Pu'o'o, we have a much more dramatic signal. It's a spike, it's hard to say, maybe we actually had a little, besides rainfall in there, or maybe something else happened, like maybe a little rockfall got pushed by maybe the rain caused a little rockfall, or maybe there was a bolt of thunder or something by the station. I have no idea. I don't know why it happened just in that particular spot and anywhere else, but it seems like something kind of funny must have happened over there.
Yeah, and it underscores how sensitive the tilt really is. It's picking up all kinds of things, and so we have to sort that out from the noise. And so we're giving you ideas about things that could affect the signal. But one of the things at Pu'uo'o that's been in the reports is this is one of our only clear inflation trends that came up, and now it seems to have slowed down inflating, or maybe even started to deflate again. But then we have this anomaly, and so once again we have to give everything to the rain right now and see how the signals adjust after we get through this spot of rain to make a better decision about what's noise and rain versus what's magma. But this is the inflation that they've seen in the middle of the East Rift near Pu'uo'o, and it's not inflating as fast as when it got up to that level. So we'll see what it does after this. We'll try and piece together the noise. Yeah,
it seems like the signal might be most clear through here, and then right here you gotta take a break and pick up after this weather settles off. So we don't really know what's happening.
Yeah, Harry would say ignore it for now because with all the rain, just ignore it right now.
It's interesting. Some of our stations don't actually show that. For example, this lower rift station, it's hard to say that maybe this drop was a little bit of the rain, but it's hard to say exactly that was it. It's a much smaller effect than anywhere else. But kind of there you go and see it. Here we actually had a deflation that was maybe kind of flattened out before it started deflating again over here, right? So all in all, there is nothing conclusive that magma is coming into the volcano. If anything, it was coming in this area, in this location over here, in kind of an isolated area where it's not clear exactly what happened there. But long term, that's kind of a very small signal. You're looking at a range of, from a little bit above -2 to a little bit below +2, so less than 4 microradians, 3.5-ish, something like that. So really not a big signal. If something's happening on there, it's not something that would immediately cause anything to crack or anything to happen like that, right? The only thing that this activity could do is build pressure slowly over time, eventually push its way back through the conduit that exists already and try to force its way out the hole that's already there. And to do that, it's going to have to, do a lot more of this, a lot larger magnitude than we see right here. So nothing imminent, even in that kind of situation, regardless of whether we disagree of how likely that is or not, we still don't see the signal of that happening right now.
Yeah, we're in the wait and see period, and these are that's one of the stronger signals we've noticed in this period where everything is still basically flat. So that's one of the persuasive signs that might be a real sign of refilling of the rift, but we're still in this very flat, very, very conspicuously quiet stage. So it's not like indicating anything that we can go off of or react to at this time. So
Right.
that boils it down a little.
Yeah, and maybe I can just share a little bit of the discussion we had online a little earlier, as far as like what I was saying, my personal view on the tilt, that there is a magma signal embedded in there, but the options of what could cause noise of this size signal, there's so many options that as soon as anything happens, like a rainstorm, I'm willing to say, okay, well, we just gotta ignore what's happening with this signal until we see something different happening. And even without a rainstorm, I'm a little more suspicious than most people, just because maybe there is a gas vent or a steam crack, or who knows what's happened. Maybe the groundwater is moving slightly differently underground in another area, and we can't no way to tell that, what I would say is that okay, maybe there's magma in there, maybe there's not. Maybe the signal is something we can see. But not always clearly, basically. And when it exceeds that, I put out that arbitrary 5 microradian threshold, just because, when you're gonna get above that, then most of the time that's a big enough signal that it's not those other noise signals. You can say, okay, well, that's definitely something to do with magma, rather than like maybe it is, maybe it isn't. And when we're trying to make decisions, life decisions, that's kind of where I've been coming from. Like, well, you just don't know, and maybe it is, maybe it isn't, but we really can't conclude anything from that. So that's kind of where I come from. Yeah,
well, and I can agree. First off, but was that the but was for my opening?
The but is that there are times when there isn't that much noise, and you can tell things from small signals, right? And that's where you're coming from. Is that?
Yeah, I'm treating some of these signals as if they were real, but I have to wait to see if they're enough to react to. So that's exactly like Phil's saying, is that everything we're gonna discuss, and we're gonna do some theoretical talks in this update now, we've got to ultimately relate it to how do we react for the people who are living on this volcano, who need to know what the safety issues are. And with these small of signals, we have nothing to react to at this time. And so that's an important way to boil it down. If we had that 5 microradians or better, then that would give us the confidence to be like, okay, things are changing, and they're changing now. Right now, we just have a hint of a change, and so we wait. So.
Right. Yeah, and kind of similar to preface our diagrams, and they're kind of theorizing here. We don't really know what it looks like underground. This is the best information we can kind of glean from all the years and years of different studies of whether they're chemical or geophysical or what have you. And so we'll share that with you guys, and you guys can ask us for sources of particular information a little later on. We're going to try to synthesize it all for you guys, so it can kind of come together and answer some of these questions that surround this eruption that you guys have kind of had for a while. But before that, I'd like to kind of show you guys the most recent images we have of the fissure. So let me show you guys, first of all, the time lapse that Dane DuPont put together for Hawaii Tracker. And let's get this thing going. Let's see if I can get let's go there by turn.
Big thanks to Dane DuPont for preparing these little time lapses. We can learn all kinds of things when we put the time lapse together from the images. So it's very useful that he takes the time to set these up and save the images for us.
Yeah, so this is a time lapse of overnight in Fissure 8, and what you guys see is there was a small glowing crack. The crack is widening. Where did my pointer go?
Oh, here's one.
Okay. So you guys see that that's the original spot out of the crater was that big, and then the cracks form on the side, and eventually the hole opens up much bigger than it was earlier on. Right. So that's the overnight view, but I can show you guys also the view from. Let me pull up the picture here. Show you guys a photograph that Dan had got for us. So here it is. So this is the image here today from 10:43 this morning, I believe.
You can see that there's that glowing edge, is that shadowed edge now. That's where it collapsed inside of there, and you can kind of see what started as that maybe 30-foot wide hole that Ikaika Marzo got some of the first footage of was over here. The Hornito was here, and now it's expanded towards the camera this way a little out of view, and it's expanded further towards the back of the fissure there. And so this is the edge that was widening and glowing in the time lapse that Dane DuPont caught for us there.
Yeah, you guys can see the hornado is actually missing there, yeah?
Yep, no hornado anymore. Fell into there somewhere.
So I think we have an image from the day before, no, a couple days before.
Yep.
They're from the 3 days before.
Yep, and there's the spattering hornado, our little oven, and there's the beginning of that hole opening up. And that was already a pretty large hole. You just can't really see it very well from this angle. But then it consumed that hornado and then extends further back into this other silvery pad today.
So I'm going to go back and forth again.
Mm-hmm.
Let me see if I can do this a little more, a little less swipey. Right.
Oh yeah, that makes it really clear. Cool.
So a couple more back and forths for you guys there. You guys can see how that thing has really opened up.
Yep.
Over the last 3 days. The before, and one more last time the after.
Very amazing.
So yeah, that's all we have from Fissure 8 right now. Although we did have the passage of Tropical Storm Olivia yesterday that kind of came through north of Puna, that affected the northern part of Hawaii Island and heavily affected Maui. And our thoughts are with all you guys who are over there dealing with all that flooding. We know what that's like. But for people who were in Puna near the fissure and even up here at Kīlauea Summit, we had some south winds yesterday, southeast winds. And we've had reports of people smelling the sulfur gas, whether it's SO2 or the hydrogen sulfide as well, in various areas around. And we still believe that that's mostly just the wind effect. Of the wind blowing these very small amounts of gas coming out that we can actually smell very, very well.
Yeah, and the gas is super important, and we always pay attention to the reports when people say they're smelling it, but so far our latest confirmed measurements through USGS are really, really small amounts, 20 tons a day or less from the Lower East Rift, and so that's barely enough to detect, and gas is going to be a big signal. If there's anything like a reactivation, expect more gas would be the main signal. And so until we get some measurement that the gas is increasing, we got to treat our people's experience smelling it is mostly atmospheric conditions, the way the gas is blowing. But as far as we know at this time, there's very little gas overall, especially compared to what there was not long ago. So important to notice.
Yeah, for sure. Yeah. So I mean, we're still waiting. We're still relying on the USGS to give us those SO2 measurements updated, and also people to tell us when they actually see, because if there is a big amount of gas coming out, you'd see a bunch of gas. But there's a caveat to that. Is days like yesterday and today when it's pouring rain, you're going to see a bunch of steam coming out of there, and that's not exactly what it is that we're talking about, right? So that's kind of misleading. People have talked about seeing that big steam cloud yesterday and kind of starting to freak out.
Yeah.
But that's just the water becoming steam in that giant hot flow area and making a big steam cloud from that.
So it can be kind of ominous, and that's important to note. Just to interject another side of that is like everybody who's been near the eruption and the fissures has a little bit of that post-traumatic stress syndrome going on, and so every time we smell gas, it's like it brings it back, and we're worried about what is actually going to happen next. And we all need to calm down about that a little bit. A lot of people have come to me saying they saw the gas plume, it looks really big, and then they share a video, and I'm like, okay, that's not a big gas plume. And so we all can just, until we get more official word that things are changing in that regard, it's at a real low level, and we can kind of remain calm about the gas because we're just not detecting a lot of gas. We might be smelling it here and there, but the gas coming out is not large, and even sometimes the visual look of the gas, when you look at it, it's not actually much gas or much steam cloud compared to what there was. And so we have to try and always frame our discussion with like, is this gonna merit our reaction to, is the safety concern changing? And at the moment, the safety issues are not changing. We have very low amount of risk or danger associated at the moment because we're not seeing gas. we're not getting indications that anything is imminently going to be reactivating or getting worse. So just want to speak to that. Just remember that we're all a little shaken up from what's happened over the summer, and one moment at a time, again, until we see the signals that we just don't have an indication of increased gas at the moment.
Yeah, for sure. I think that's probably a big reason why I think we saw that someone on the tracker team pulled out a USGS comment. But the USGS says that their clock has not been reset.
Right.
Did you see that?
Mm-hmm.
That their clock has not been reset by this kind of puddling activity, you know, so you can argue whether that's right or wrong, but that's what they're saying. And if they're saying that, they must be basing it off the gas, I would imagine.
Yeah,
more than
gas
anything
and
else.
the deformation too, and I respect that. So for me, you know, playing devil's advocate here, my clock restarts every time I see lava in that vent, but that doesn't matter for public safety, you know. And when USGS talks about their clock, their countdown of a month, that's not a set in stone scientific principle. It's just about a month is a good amount of time where they can imagine the average length of a pause, and that should be enough to judge that it's still winding down rather than acting up. And so it makes sense that they're not resetting their clock based on this activity, because we don't have the other signals that suggest that anything more is on the way. And so while I'm still pondering it, and so I kind of start my month again every time I see the lava, shouldn't be affecting our judgment call for what the risk is. We don't have the deformation, the gases, the earthquakes that would suggest anything big is going to happen. It's just kind of the way you look at it, right? So.
Yeah, absolutely. Yeah, and you know, really, when we started talking about this whole month countdown thing, it was it was in relation to civil defense using the USGS declaration as an indication to start taking action towards letting people back in their houses, and that actually has already happened.
Right, and people are going back in.
So they've, you know, for anyone who's not around and hasn't heard, they've, you know, lifted the mandatory evacuation. You know, now it's voluntary evacuations. People can go back into their houses. You know, there are still some restrictions in place, you know, to kind of prevent looting, and not everyone is going to move back. Some people moved away from the island for good.
Yeah.
Others have no idea what kind of status their house is in, but, you know, it's not livable, so they couldn't go move into it or, you know, live there to protect the stuff. So, you know, that's kind of the surrounding things, and why they're having a phased, I don't know, transition, we'll call it.
Yeah.
You know, they've opened not exactly a lava viewing area, but a place where people can see the lava flow from Mackenzie Park, you know, so you can go and actually look at the 2018 lava. You can actually even try to walk across it. Although many people who have tried that have come back quite bloody and bruised.
Pretty sketch.
So, yeah.
And the surfers too. I heard from someone in my neighborhood, some surfers hiked out to Pohoiki, and because the reef is different, the beach is different, the surf break is different, they got totally worked and seriously injured. They loved that they were able to go and experience all that, but just be aware, it's rugged country out there now, so you gotta treat it with respect. It's pretty sketchy making the trek out to Pohoiki from what I hear so far. So
yeah, and so the county's kind of fallen back to their old policy, unless you're an organized company, but let's ignore that for now. That basically that nature is going to limit who can go out there and how far you get and that kind of thing. You better be prepared. You know, we haven't talked about it at all yet, but you know, there are some fairly important hazards in the flow field that people who are going to try to do that walk, you know, should be aware of. And kind of just briefly, you got to have enough water, right? When I walk across I always like to have long pants on, because it's likely you're going to have some rock scrape against your leg. You know, I've gotten like deep gouges through my jeans before on flows, you know, where, you know, like my pants actually, well, maybe it's slightly like scratched, not really torn, but then underneath there I've got a giant bloody gaping hole. So
it's serious turf. Yeah.
So you know, and I would definitely not do it in flip flops. Like you know, maybe some of the local guys who are, you know, used to that, but most people, unless you're really that confident, don't.
Yeah.
You know, and it's hot. Not only hot from the sun and the lack of shade, but the ground is hot, and you're basically getting baked both ways. So you're gonna get dehydrated really fast. And usually in a flow field, most injuries occur when you're dehydrated and pass out or trip or something along those lines, because, you know, when you're weaker, dehydrated, that's when you're most likely to injure yourself. It's just like playing sports, right? At the end of the game, when you're dehydrated, and that's when you're going to pull your muscle. And it's not that different a physiology thing, so normally the biggest safety thing for me when I gave tours was, drink as much water as you can, and that kind of lets you help you keep your head, and then you're going to avoid most of the other problems. That's kind of the number one thing. So if I, had to just briefly say that, that would be my initial things. When we did tours over lava flow, over outflows, if we ever had to, we'd always wear gloves. So if anyone's a tourist, then clearly if you got a surfboard on your back and flats on, you're like in a different category of person, right?
Different category.
This does not apply to you. You don't have to take our advice at all. You know what I mean? Like do what you got to do, but for anyone else who's doesn't know what's going on, that's the word. Yeah.
Definitely.
So yeah, that is our...
Yeah, it's been amazing, kind of related. It's been amazing to start to see some people's stories of going back into Leilani, reclaiming their houses, and it's just daunting work that a lot of people are facing if they were anywhere near the eruption sites, and still have their houses to go back to. They have just unimaginable amounts of work to do. And just the emotions of seeing the neighborhood, seeing the extent of what Fisher 8 has done. It's really amazing to see people's stories, so I'm really appreciating people sharing some of that as they go back in. And it relates to what we were just talking about. Everybody's threshold for moving back in is a little different. Everybody's month countdown is probably a little different. I have friends who live in Leilani who are far from the Fishers, and they're still kind of waiting to see if they feel like they're ready personally to move back into their house and see how it goes, So got to respect that everybody is in a very different situation, and everybody has a different feeling about the risk and how long they want to wait. So we're in the middle of that, and it's all rolling forward. So it's been really great to see people's stories of moving back in and what they encounter, and it's just so amazing. It's unreal. So thanks for sharing that, everybody.
Yeah, and kind of while we're on that, I want to bring up that I went down to I was in Hilo yesterday to attend the High Dart meeting, and for those guys who are not aware, the Hawaii Disaster and Assistance relief team. I think I got that wrong. But the High Dart is basically a group of all the different agencies involved in a recovery effort here. So I know people have been really frustrated with how the process has gone to try to get aid, whether it's from FEMA or from the state or any kind of Red Cross, all those different things. And what the High Dart is doing is they put up a webpage where anyone who's affected can apply for these services under one individual form. So you basically put in one form. They kind of assess what your situation is in particular. They'll kind of direct you to the agency that's most likely to approve something that's useful for you. So if automatically don't qualify for one reason or another, they basically just skip that whole step for you. So I heard someone say yesterday, instead of having 15 applications to 8 programs and you're only going to approve for one and get denied for 14 of them, you can put in just one form and they'll just basically funnel you to the right one, and you don't have to deal with the 14 denials kind of thing. That sounds awesome. It's amazing that it wasn't in place before now. Right. It's clearly needs to happen. So anyone who's not gone through that process, because it's too daunting, you can maybe check that out. The High Dart. It's DART is DART. Or is it 2 R's or 2 T's?
I think it's 2 R's.
2 R's, yeah. DARRT. It might be a dash, HI dash DA. Yeah, I'm not sure. I have to look that up.
High Dart.
High Dart. Yeah. But anyways, yeah. So check it out. Yeah. And so for example, one thing that came up is in particular, I could say that Catholic Charities Hawaii has grants for people to actually clean not only your gutters and your roof, but your entire water catchment system, right? All the way down to cleaning out your catchment tank itself without draining it even. So they have some qualifications that apply, like you have to have evacuated, either from a mandatory evacuation area or for health reasons from a voluntary evacuation area. But if that's the case, anybody can contact them and get them to use their grant to help you clean your house. So that's just one example of the kind of thing that they're happening there. They've been all the different groups. I don't have a list of them all right here in front of me, but they're different. Whether it's Red Cross or Salvation Army, whether they're offering meals or actual provisions, or in some cases, airline tickets to get off the island, you know. The whole range of everything that's available has basically been represented at that meeting, you know, and everyone's trying to work together, all the different agencies to kind of cast, the way I've been thinking of it is to cast the widest net and, you know, eliminate as many holes as possible so everyone can kind of get covered as much, you know, under some way or another. Not everyone's going to qualify for the same program, and that's been one of the challenges, figuring it out, and agencies not talking to each other, you know, so that's kind of what it's been all about. So for you guys can check that out. We'll try to keep involved in that and give you guys all information that's kind of pertinent. And thank you guys for posting the website. I see it down there, highdart.org. Yeah, so cool. Check that out, you guys. So yeah, there's a lot of activity happening as far as recovery. You know, even as we debate the fact that lava is still in there, you still see glow, and you know the summit's story is never done, basically ever. So we'll kind of turn to that, you know, shortly here. Is there anything else before we get to the earthquakes?
No, I think those are positive ideas that things are getting more coordinated for people recovering from all this. That's awesome.
Right. So even if it wasn't, you know, that great this time, ideally, you know, when something like this happens again, we'll be a lot more organized as a community, you know, because, you know, like the Hawaii Red Cross leader and the Hawaii Salvation Army leader and the Department of Parks and Recreation leader, they're all based here, right? And they should be talking to each other, you know, like ahead of time of anything like this happening. And it took this kind of event to really bring us all together to the point where we got that organized, you know, necessarily. And unfortunately, we had to suffer. A lot of people had to suffer through the, you know, that inefficiency early on. But so
it's hard for people.
So yeah, that was something we'll continue to report for you guys as we learn more and time goes on. Cool. So let me load up the earthquakes page here, and let's switch gears a little bit and talk about what's going on there. So here we go. And let me give it a refresh just to make sure we're up to date here. And what we got going on today on our map is in this area, it's showing us 15 earthquakes. And of those 15, we have our fairly typical distribution for the past maybe week or so now. We've had a whole group of them on a south flank. They're kind of spread all along the south flank. And that in itself is, you know, just showing that it's still adjusting, still moving, you know. There's not enough of them to believe that there's anything major happening here besides that kind of settling, you know, although we may in hindsight look back at this as a sign of the beginning of something else. Right now, there's no indication that this is anything other than the typical south flank movement adjustment that's been going on. We have our earthquakes at the summit right in here, which are getting more frequent than before. They seem to be, you know, none of them are very big. They're all in a magnitude 2 range, you know, slightly below, slightly above 2. And the fact that they've picked back up again is definitely interesting. You know, we don't see anything major at the summit, like there's no huge deflation or anything like that would lead us to believe that there's magma leaving, so it's hard to know exactly what's going on there. It might just be more of things settling as well. What we have had a lot of, you know, is rain, and, you know, one thing that I always keep in the back of my mind is that water does lubricate faults at depth, and so sometimes when you have things that are in a kind of unstable position, a bunch of rain can help them settle in a way. That's one way of thinking of it. You know, allowing them to kind of get to a more stable equilibrium. You know, the rock can settle a little farther down the slope or what have you. You know, that's one way to think of it. So I'm not discounting this as just being kind of still settling. Besides, the other option of, for example, magma is leaving somewhere farther down there, and we just don't see it. So basically, I'm going to call this business as usual, and business as usual over here as well, right? And similarly, we keep having these deep earthquakes in the Pahala region. So here we are. This is just in the last day. So let me kind of push a button here and make it for the last 7 days. Continue anyways. So you guys can see that. Let me zoom out slightly. All right, so we have a whole bunch just in the last 7 days in the Pahala area down in there. And you can kind of see that the overall pattern, just kind of zoom out and see we still have those summit ones, we still have our flank ones. It's kind of a similar pattern as we just described, right? Summit ones, flank ones, and here's our Pahala ones. So all these Pahala earthquakes are all very deep. Let me see if I can get the, yeah, that's probably pretty good. So let's look at our list here on the left and just kind of scan through these. 2.4 at 40 kilometers down, 1.8 at 35, 32, 30. That one is not one that was, that one is a different one. That one's actually all the way up there. So that one, okay, that one doesn't fit in a pattern, fine. 32, 31, 44. There's another one that doesn't fit in. It's actually right in the area above ground. 22, 30, 34. So we see there's a range of these, right? They're not all at the exact same depth. There's a whole range of them, although they're kind of more or less in the same areas. Mostly in the 30s. All right, let's call it, you know, we have one that's at 22, but mostly in the 30s. There's one at 44 and one at 40, you know, mostly 30 to 40 with a couple of outliers is basically how we have these earthquakes. And we've suggested before, you know, that some of the thinking was that there was a deep conduit of Kīlauea underneath this area over here, and then maybe connected further over to the main summit area over there. So we've been doing some research and looking at some of the more recent thinking about this to try to understand what might be happening there and help you guys understand what's happening there. And I'm personally not as convinced anymore that there is any kind of deep conduit over here. I actually might lean towards it existing underneath Halemaumau all the way down, and actually having movement, that conduit allowing movement to happen on the south flank at a great depth in this area. But to explain that, we'd have to show you guys the diagram. So, are we ready for a diagram?
And now it gets exciting. I love the diagram.
So John is super stoked about this.
I got the whiteboard. I'm just happy we get to use it.
Yeah. So let me kind of reposition myself here, and I might come on this other side of you so I can avoid the glare.
Sounds great.
There we go. And we can show you guys a few of the things that we have drawn in here. So let's start off at the very, very top. Okay, so here is this kind of plumbing system that we've drawn for you guys in the past. The only slightly different thing here is we've kind of drawn that at a slight angle, right? So we're going to say that this is southwest at this end and northeast at this end over here. So we're kind of slightly askew, so our rift zone doesn't look quite as long. Kind of the rift zone goes
this way and then away from us in our drawing.
Yeah, into the board.
Into the board off that way. And so these would be like Manaulu, Pu'uo'o, and Leilani all lined up along the rift, but away from us there is what we're trying to show.
Yeah. And likewise, the southwest rift would turn and come towards us out of the board.
Out of the board towards us this way.
Right. And so our previous diagram we drew you guys basically had the scale on the left that was from 0 to 10 kilometers, 0 to 6 miles or so. And you guys can see that what we're doing here is we're zooming way, 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 way out. Right? We're zooming way, way out to where we're down to 70 kilometers on the left of our scale and about 43 miles on the right.
43 miles down.
So, so we'll kind of talk through what we've drawn here on here for you guys and maybe expand it a little bit. But basically, you guys can see that this whole rift zone system is all at the very top. That, you know, basically that very surface part of the volcano where it's spreading out, where there's the gravity is low enough that all this rock above here isn't pushing down and kind of keeping things in. So John is pointing out...
That's sea level, that dotted line right there.
Yeah.
So that's where sea level is compared to our mountain. So you see even the most shallow part of this is really deep compared to us, below sea level. Yeah,
exactly. Now, Kīlauea, Mauna Loa is over here on the right? So, and actually Kīlauea is above Mauna Loa. So this dashed line right here indicates the boundary of where Kīlauea has come through and erupted on top of Mauna Loa. So, so there's that. And a couple other lines that are drawn on here. This blue line down here that's separating the ocean crust. This is just actually like a... so this is the pre-existing crust that made the sea floor before the volcanoes erupted onto it. And below that, we have what I've written on here as a solid mantle, right? That's just a chemical difference. You have a lot more, basically olivine is the bulk of the rock down here, as opposed to above it. So, but this is actually all solid. This is solid, and this is solid, and this is solid. And the reason we know that is because there are big earthquakes that happen down in the area over here. And those earthquakes are kind of, we'll show you guys a map of a diagram of that here shortly. This is where we infer these deep, what we call basal faults to be areas kind of below the whole stack of the volcanic pile, as it's often called. right, that kind of moves off to the side. So that's basically the scale. Down here at the bottom, we're not exactly sure. It's not quite clear what this magma generation zone is like, but it's at some depth, somewhere in the area. You know, we've drawn most of the things in here, like this conduit, as kind of solid lines, but really it's a network of cracks of these vertical blades that are dikes, as we call them, and horizontal ones that we call sills that kind of interconnect to form a pathway up. We've drawn it straight just to make it simple from this part, but it may be something more like this at depth, where it kind of all kind of comes together and feeds the system way, way down. We're talking about something like 40 miles down there. And we haven't drawn it on here, but Mauna Loa would actually be off of our thing to the right, and Luihi would be off of our thing to the left, as similar generation zones that kind of come through the whole stack like that, right? Okay, so let me show you guys a graphic that is from a paper from 2004 by Cicely Wolf and others, who are examining the deep earthquakes here on Kīlauea. And let me pull it up here for you guys. This one right here. So in this paper, we basically have a couple of views here. So let's ignore this thing over here on the right for now. Okay, let's look at just this plot. This is basically going to show us the area we're gonna slice through to look at the earthquakes. So here's the summit of the volcano, and we have a rectangle here that we're basically going to take and squish and look at it from the side, right? On this particular map, what we see is the different colors indicate depths of the earthquakes. So, for example, these kind of purplish ones are the ones in the range of 10 to 20 kilometers down, right? We're not even dealing with the shallow stuff here. Everything here is all below the rift zone, right? Below this even deep rift concept, which we can point out in the map here shortly. But basically, this is all the deeper stuff. So there's these kind of likely Kauiki events and that kind of bound Kīlauea and Mauna Loa up here. There is this kind of greenish area between, call it 30 and 40 kilometers down, that extends from the summit all the way under this Pahala region, all the way down here, right? All more or less a similar depth, all through here. Almost like a big sheet that shows, you know, there's a predominant depth where all these things actually happen through there. And a bunch of other stuff that happens farther on to the side over here. We're going to kind of just gloss it over for now, because I want to show you guys a slice that goes through here. And there it is down here. Okay, and so now the colors mean something different. Now the colors mean a slice through longitude. So for the purposes of our discussion, you guys can assume they're all kind of just stacked and giving us a representation of what the volcano is like on the inside. So the thing is, earthquakes have to basically break solid rock. So when we're looking for magma, you have to look for areas where you don't have earthquakes at all. So when we look at this, and we know that the summit of the volcano is up here, and the summit caldera is up here, and we look straight below that, we see there's a big gap in earthquakes straight below there. So this is likely the area of our conduit that comes up to the volcano, up to Kīlauea, right? And just like I mentioned before, Mauna Loa is off to the side and Luihi's off to the other side, so this is basically just a Kīlauea thing, right? And so there is basically an area with magma conduit. Just because you have areas that don't have earthquakes doesn't mean it's magma over here. It just means maybe don't have any kind of fault. This whole thing might be moving more solid than other pieces in between. We see a definite fault line down in here, an area kind of at the base, near the base of the volcano, that we'll point out in our diagram here as well. This is, you know, between 10 and 20. And then deeper down, you see we have a big fault line that seems to kind of cut across this magma conduit and has a trend that goes down like this, right? You see it kind of clearly goes down this way. You might think there might be a splay that goes off this way, possibly. There is definitely a line that goes off at the bottom, goes like this, right? And it's got its own little splays as well, here and here and here and here. So it's a little bit hard to kind of catch all that from this diagram. So what I've done is I've just sketched slightly on here a little bit as a starting point, you know, more or less where this conduit should be, somewhere in there, right? Kind of drawn out where these fault lines actually could be, like that seems to be one there, that seems to be one down there, here, these things are kind of, don't really see them in this area over here. And this might be the area where you might say, okay, maybe there's magma in there because we know the magma is quite close to there, right? when we discussed the possibility of a deep conduit underneath Pahala, it was this area over here, this kind of little gap in the earthquakes right in there. You guys can see there's a little zone with not as many colored dots, right? So, but for the magma to actually take that pathway, it would have to come up through there. We know it doesn't go straight up, which is why we had to invoke some kind of sideways movement for it to come back up again. So that is possible, that's the path it takes, right? But it'd be much simpler, and it seems a lot cleaner to put it up through here, actually, than it is to put it through here. I don't know if anyone else agrees with me, but that's just my personal take there. When we look at different sections across different parts of the volcano, like farther east, for example, we still see this big blade kind of coming through here. So let me see if I have one of those to show you guys. It might be hard to pick out right here, but yeah, this is one that's actually from a slightly different area, but you see that similar kind of pattern, that big blade down here, and even some other, maybe not quite as clean farther down in there. But basically that's a big discontinuity which exists within the volcano. So we basically have taken, where'd my thing go? Oh, there it is. This one. Taken this, and we've translated it to this board. So this image is what we've kind of drawn in right in here. So hopefully you guys are following. I know we're kind of getting technical here with you guys, but so this is kind of where we infer these fault lines to come from, right? There and there and there and there. All right. So Pahala is basically over here somewhere, and these deep earthquakes are happening down here. Here's our possible zone of that possible plume coming up, right? But the thing is, we see earthquakes happening all along the area over here. Let's get ready for a demo here, live demo here, John. Let me get the earthquakes up over here so you can see them. All right. So there, I'm gonna walk around here. All right, so John can look at the earthquakes, and let's.
Okay. So the earthquakes, deep Pahala earthquakes, are happening along a couple of these plains in here. So there are faults down there, and so most of them are at that similar depth that mirrors this fault. So our deep earthquakes under Pahala would be happening somewhere around in here, right?
Yeah, exactly, yeah.
All along this fault, and they're clustered along that area that moves, which would be along the fault.
Yeah, and we're kind of focusing on ones that happen right under Pahala, but they happen actually all the way back up. So let's draw some in some of those also.
Yeah, so they'd happen all along these.
The ground's shaking, you guys.
Here.
Earthquakes.
Earthquakes, these are earthquakes. So sorry I'm putting on so many of them. It's just a demonstration.
Yeah, imagine we're flying through time here, and this is what you guys this is happening, right?
So we get lots of them in a certain area, more frequently. But all along here, the longer time frame you get, you would fill in this whole fault with more and more quakes that are associated with that same plane, that same line, and same below it here too.
Yeah, and you actually get a whole bunch in that little point of the wedge on the left, right? If you look at our map over here.
Over here, yeah, there's
right. You guys can see there's a whole bunch, and if that's a geometry of that thing, you would expect there to be a whole bunch right where that thing kind of pinches together. And I've tried to simplify, where I draw the faults, but there's probably splays of these things that go all over the place in there. In between it all, it's all kind of all cracked to who knows how many, what levels.
Splays,
and it can kind of, there might be some zones in there that are actually just a bunch of, ground up rubble in some ways,
So it slips
that basically becomes the actual fault zone, not just one particular fault plane, but a whole area that, just like the rip zone at the surface, might be something like, half mile wide underground kind of thing, So given those earthquakes and the movement of the fault, which is basically that everything is moving towards the ocean, right? Going that way. Yeah, exactly. That now let's think about when that fault to move that way, right? It's moving that way largely because of gravity, but also because of magma pushing at some points, right? It's kind of the long-term model that we actually have, right? So without really knowing, that the magma at that depth could push the fault that far over, we could say that the fact that the fault is next to the magma might actually cause that conduit to interact with parts of that fault right where we have those dashed lines, right? So let's draw in some possibilities, and just guys know, we're totally just giving our best educated guess here. We don't know any of this for sure. It's just kind of, what makes sense to us as far as, how the system might actually work dynamically.
we're entertaining some theoretical ideas here, but it should just represent the scale, how far apart these things are happening. And if we had magma able to, is this what the part you want to get me to? The intrusions happening along these faults.
Yeah, possibly, yeah. But what I would argue is that where you have the earthquakes kind of excludes the zone. So that particular piece of fault right there with the earthquake so close probably has the least amount of intrusion compared to the ones above and below it, right? Because we don't see earthquakes there. Okay. So that likely has a bigger
intrusion.
There could be, we could actually have that kind of magma intrusion in those areas farther down there. It's hard to know. And, we're drawing just like there's 3 lines in there. This thing could happen, there could be more regularly spaced. There could be a lot more of them. Who knows how many of these things are happening underneath there. And the point is that when you have a lot of pressure and you're able to kind of push magma into these areas next to these faults, you might then allow those faults to move more easily, right? So, if everything else is equal, then times with more pressure, those things move more than times with less pressure, right? Okay. So we don't need to have this deep conduit under Pahala to explain any earthquakes right above there, do we?
It could be pushed from over here.
It could be pushed that way. In fact, this whole pile like we just talked about is moving that way, right? And we do kind of see those clusters in a particular area underneath Pahala in particular, but it could be that some areas of the fault move more easily than others, right? So some areas could actually slip without earthquakes, and other areas might be catching all the time. And it seems more likely that this area under Pahala is an area that catches all the time. So when this thing is pressurized and actually pushing that fault, then it basically is showing that area of stickiness is showing that the conduit possibly might be more pressurized than not. And at first, when I first described that conduit, I thought, I've been saying, well, earthquakes themselves don't mean that the pressure is rising. It could mean some change in pressure to be lower or higher, both, right? But I'm feeling now that it's been so long, that these earthquakes have been so persistent, that if they were really a collapse, it's harder for them to keep collapsing for so long. To address your question directly, Nathan, finally, however many minutes later, 20 minutes later.
You mean these are not collapsing in? Is that what you're saying?
Yeah. So I mean, if it were collapsing, then it should only collapse so far, and that should be the end of it. It shouldn't kind of collapse indefinitely. Whereas if it's pressurized, it actually can inject and keep popping indefinitely, actually, right? The thing to remember about this thing is that this is what we call subhorizontal, right? So we got to slice through here, right? But these things are flat like the shape of John's hand is right now. They're not coming in. Yeah, that's how they're coming in there. And at the surface, John, show us the direction of the dikes at the rift zone, even though your hand's much bigger than them.
Oh, at the surface?
They're like that. Yeah, so that's the orientation of the blades. Yeah. And down lower,
they're sills. They're flat.
They're flat like that. Exactly.
So here they're like that. Down here they're flat.
Yeah, exactly. So because you're injecting those flat sills, right? It's going to cause, it may actually have some kind of popping action, right? Where like you can imagine if the pressure is low, it's going to basically pinch off that thing just from the weight of the rock above it. There's literally 20 miles of rock above that, right? That's a huge overburden, as we call it in geology, that is likely to keep any kind of crack down there as closed as possible all the time. So if the magma pressure is changing more and less and more and less, then it actually could be reflecting that as well. And so in my mind, to actually have persistent deep earthquakes in the area of Pahala for so long, it's been I want to say since the beginning of June now, right? Well, how many months is that? 3 months? 3 months of deep earthquakes in the area, to me, does not quite jive with the collapse. The collapse model is, jives more with the thing being pressurized down there and moving out. Now, we don't really, we kind of just, clearly no one can see 20 miles underground, right? We're kind of using earthquake energy as our proxy and all the data that we have, and compiling all information that we have to the best model that we can kind of put in right now. And We may have something blatantly wrong here, but this is the best we can come up with, kind of synthesizing several papers that we've kind of examined and talked about of how this may actually be working. And that may be why we have those persistent Pahala earthquakes. And that's important to us because we've been talking about long-term patterns of the volcano as they relate to how much magma is coming into it. And this would be an indication that a magma pressure down there is still high. It has not dropped, right? So pressure has been high recently in the sense we've had a long-lasting eruption at Pu'u'o, which, that part just ended. We had a big eruption in Leilani. That just ended. But did it end because the supply went down or because of something else is the kind of big question, right? So, I'm kind of leaning now to the side that it is not less lava, less magma. Yeah, it's actually just the way the surface is adjusting to it, right? That upper little slice of our diagram right up there that we've barely talked about today, right? That's above all the stuff happening way, way, way down. So, those deep Pahala earthquakes are not something to really, really worry about eruption-wise. They're related to the conduit itself and the conduit pressure and how the conduit puts lava into the volcano. But it doesn't directly feed an eruption in Pahala, which is probably what most people are going to be scared of. Yeah. So that's not the case. Right? These sills, sill is a specialized word, right, for this kind of sheet of lava that comes in kind of flattish, whereas we use the word dike for the one that's up and down.
So a dike would be
the dike would be up and down like that, yeah.
Vertically.
Right? And it all depends like which direction all the surrounding rocks are squeezing you hardest. At the surface, you have a lot less overburden, right, a lot less rock above you, so the easiest path out is up most of the time. Most of the surface features have this kind of vertical orientation. And the deeper down you get, the less important that becomes compared to the mass of surrounding rock is almost equal on all sides at that lower depth. And that's why you often have this different orientation. So these sheets that are coming in under Pahala, they're flat and none of them is reaching towards the surface, right? And even if they were, they're still 20 miles down and you don't have to worry about lava breaking out at the ground in the middle of Pahala just from earthquakes 20 miles down.
It's not coming up this way.
Yeah, yeah. The model that has been previously described, it actually would go up along the bottom of that and then connect and go up that way. And, that's possible.
It's possible. That's why we got a lot of questions.
Yeah, so we got a lot of question marks in there, but that's our basic, big picture to share with you guys of how it might be working. And
there's a lot we can also demonstrate now that we've drawn all this out because, we worked hard to try and represent the scale here. Everything else we've talked about is happening in the rifts. Even when we talk about the deep rift, that's all really shallow within the volcano, and the volcanoes are being fed by the hotspot sources so much deeper. So just understanding, we're talking 30-something miles below ground, miles at this level. And the magma has to reach all the way to the surface from that kind of depth. It's nearly twice as hot, the magma, when it's way down here. It's cooling the whole journey it takes up here. Even if it's going this way, it's losing heat as it comes up through. And again, we've talked about it several times, the magma should be buoyant. And so like a bubble of air, it's buoyant, hotter, and full of gas compared to any of the other lava that's sitting in here. So it wants to rise all the way to the top of the system, which would have been the chamber right under the caldera, which is now collapsed before it goes out into the rifts, yeah? And so we think that it percolates all the way up to the top before going into these other rifts. But then we've drawn in some other ideas here, in one of the leading models, the Eastern Rift is connected at the shallow level, at the top of this larger magma reservoir we call the South Caldera Reservoir, and it travels horizontally through dikes out there. And so the dotted lines we put in here, that's about how deep the deep rift would be. If we think of new intrusions taking the form of those vertical dikes intruding in, that's how much distance they would be, like 6 to 10 kilometers down below the rift. Might have intrusions of lava when these new vents open up. But see, that's all really shallow compared to everything else we're talking about. And when we think of this, we drew in this question mark here because some of the models suggest that the lava comes from really low down in the South Caldera chamber and is able to detour past all this other summit storage and into the rift that way. And those are things that are hotly debated, if you will. And so we don't really know if lava can be diverted this way if there's no pressure in the summit anymore. We've lost all the pressure up here, which might have diverted things in the past. So again, the summit is all important because any of the magma coming up through the system should want to come all the way to the summit. And the question is it going to be diverted into the rift and continue eruptions in the rift? Otherwise, it certainly physically always wants to go to the summit area. And so that's super important when we're talking about what the volcano might be doing next, right? On the one hand, there's still some uncertainty if the eruption in the Lower East Rift is completely over, so we'll have to keep watching and seeing if that ever reactivates or if there's more signs. But we know whether it's sooner or later, there will be activity at the summit again. That's just the geometry of the puzzle here, the way the volcano is. I don't know how deep Phil wants to get into that side of it, but what kind of form, what kind of scenarios will be for the summit if activity continues there. So
so one quick question, the Southwest Rift is actually over here, and it goes comes out of the page here at us too, and this deep rift should actually curve around underneath this thing also, and same thing on this side. I haven't drawn it all in there to kind of not complicate things too much for you guys.
It gets super complicated, but there would be a whole region here which either has old magma or hot rock or maybe real magma, extends 6 to 10 kilometers below the main part of the rift. And it's just hard to draw all that on one diagram.
You know what occurs to me, John, looking at this now? This looks like a tea kettle to me.
I know.
It's like a tea kettle, right? Like, here's a spout, and here's a lid.
Yep.
And what happens when you try to boil water in a kettle without the lid on?
Comes out the top.
Comes out the top.
Uh-huh.
That's the analogy I'm going with.
Uh-huh. Okay. I still think we have a lid on there, though.
That's that. Yeah, we have a. It's definitely not open, right? There's definitely a bunch of rock in there. It's just more rubbly and more less coherent than having this whole area full of lava, right? And a bunch of rock all the way up here.
Yeah. I see what you're saying, and I still think there's a chance for this kind of diversion to be going on, but what is significant about it for sure is that a lot of studies indicate that if this top chamber is emptied, there's no lid, there's no pressure in this top chamber, that reduction in pressure should make it easier for new lava to come and rise to the top.
Right.
And so that's another reason that with the chamber being emptied, there is some physical reasons for the eruption to return to the summit, because there's less pressure in this area keeping it from coming all the way to the top now. And so that's a factor we're puzzling about for sure.
Yeah, so take a quick survey, you guys. How are we doing? Are we,
in the weeds?
Are we in the weeds? Diagram there. Because if you guys like, we can switch gears slightly to talking about summit patterns, because that leads directly from what we were talking about, as far as having that summit collapse area associated with rift eruptions or not. That might be something useful to talk about.
Yeah.
Yeah?
Can go in a different discussion of its own, or I don't know.
Yeah, so let's pull it up here, huh?
Okay.
In the meantime, a couple of questions that I see. How much gas is being released at the summit? You want to answer that, John?
Less than it's only about 1,000 tons for the whole volcano right now, as far as I remember. So I think it's like less than 200 tons a day from the summit area. I need to double check on that. Maybe
that's about right. Yeah, it's not a whole lot.
On the order of a couple hundred tons at most recently. So that's very low. Very low.
Right. So okay. What I want to show you guys is this. I'm going to try to keep it to just one diagram if we can help it, because otherwise it's going to complicate it too much. But this is an image from a paper, USGS paper. This one, I believe, is from Holcomb in 1987, when he's looking at the large-scale patterns of the volcano. And what we know, this is kind of combined with information that Don Swanson's been writing up for the last for the last many, many years about patterns of collapses and explosions at the summit, intermingled with eruption patterns on the rest of the volcano. So basically, we're looking at the era up to about 200 BC. I'm sorry, we're at 1500. This is from 200 BC. 200 BC was when we had our last major summit collapse. So from there, once we had that big pit, we basically are refilling lava within a summit crater, and we have very few eruptions anywhere else on a volcano. Basically, nothing happening in the rift zones at all. Right. Let's go to the next frame of time, which is from 200 BC to 1500 AD. Right. When the volcano was so full, the lava was spilling out and basically covered from the summit. Some overflows down most of the south flank and actually all the way to the area of HPP. We do have a big rift zone eruption as well. Now, just to kind of warn you guys, some of this data is old, so we haven't refined any of that and kind of readjusted any of that. You know, some of these flows have better dates and whatever else. It's still the big picture, best comprehensive story that we have to go on right now. So 1500, we have big flows kind of in the area, right? And I'm sorry, not 1500. This is to 1200, right? And then from 500 years ago would be.
So
yeah.
to the 1480.
Yeah. So okay. So this is exactly. Mm-hmm. So this would be, yeah. So then here we have in the next frame down. It's actually a little bit muddled because it kind of goes together. Yeah. This goes up between 1500 and what is that? 1700 or so.
Yep.
So it shows. In this particular image, it's showing an outflow being part of this, but it actually probably belongs here in this frame, right? Actually, so that's slightly wrong there. That should be over here, and basically we have filling within the summit, and we have overflow. You know, so actually most of this, but actually this slice is not the best one right here. But in 1500 AD, we have another big collapse, and we have to have refilling of the summit crater within that area right in there. So between 1500 and 1790, between 1500 and 1700, there aren't really a whole lot of flows on the flanks, maybe a couple of small ones over here. But then 18th century, now the 1700s, now you guys can see that we have all kinds of activity happening in a rift zone, right? This goes back to 1700s, you know, so it's hard to say exactly these dates because this is all still pre-Western contact, right? We know we had a big explosion in 1790 that we basically formed the most recent inner part of the caldera. Kīlauea was reshaped most recently then. But we also have lots of flows in the rift zone, including this big one over here, Heiheahulu, which was our best guess right now is 1750. And we also know that there was some kind of summit emission, you know, ash was blown out of there around that time as well. But basically from 1700 to 1800, we had an era of actually, it seems like a mix of at least one, possibly two, possibly three different explosions in the middle of lots of rift zone eruptions, right? And that's the most interesting one of all to me because that maybe corresponds most likely to what we're seeing now. After the 1790 explosion, in the 1800s, we can actually look and see we have not that many lava flows. Some in the rift zone, a big one in Nana Valley is very important. The big one in the Southwest Rift, Cow Desert, is also very important. But you just see the general pattern of them. You know, these are big eruptions. Both of these are actually huge eruptions. So instead of having lots of smaller ones, you know, I have two big ones. But overall, the pattern is much, much less than you see up here, right? And then since then, we're kind of back to this pattern of the rift zones being active once again. And actually we have, this map was drawn in 1987, so you guys are missing a lot of stuff here, but like pool flow field actually should extend a lot farther to the south and be a lot wider over here, big bulge, big blob over here. And of course now we have a bigger blob over here in this area over here from this year as well. So the point is that there are different kinds of eras of explosions. You have eras when you have explosions with a crater that's so deep lava can only go back in a crater and nothing's happening in the rift zones. Some eras you have explosions where we have rifts and eruptions, then explosions, rifts and eruptions, and more explosions, and it seems to go back and forth. And in this case, 1790, we had 3 days of explosions, right? In this case back over here, we don't know if we might have had 300 years or 1,000 years of explosions. We just don't have any information about that frequency back there. But what I'm trying to kind of get at is what's going on, what's a clearest indication of what's happening now. And I'm going to point to 1790 as our clearest analog right now. You know, I don't think that we have the same kind of collapse as 1500, the one that happened back in here, because we don't see similar kind of collapse features to the south over Kīlauea area in particular. That could still be coming, so that's something we're definitely be watching. But the point is that we actually could have pulses of movement of the south flank, possibly, that could accommodate rift eruptions, followed by collapses and explosions when lava comes back through there. So you might imagine an explosion, then rift, and then basically you might have some, if you have a big enough eruption, you may induce a summit collapse, which causes another explosion the next time lava comes back through there. And this is kind of like a it's not a stable exactly process, but it's actually like a persistent pattern where you can have both together, right? So there's actually 2 different kinds of explosive eras is what I'm trying to get at here. And based on that, it's important to know whether the supply rate to the volcano is high or low, because if it's high, you'd expect it's going to come back through here and refill this and erupt in the rift zone like it did in the 18th century, right? And if the supply rate is actually low, then you'd expect something different, like that, right? Lava just in the summit, maybe not in the rift zones, right? At all. So the fact that we're talking about our big diagram over here and talking about the Pahala earthquakes and, the fact that it might indicate larger pressure, that we may, based on this, believe the magma is still pressurized deep under the volcano, best guess, it is just a guess, that the supply rate has not gone down, right? I also have a hard time believing that it could go down from 1 month to the next that quickly when everything else in the volcano takes weeks and months and years to adjust, right? So, that's kind of where I'm coming from. So I think that we're in a pattern like this where lava is going to come back into the volcano. Depending on how long it takes for that to happen, it may cause an explosion at the summit. I would predict would not last for years and years and years, but rather days until it kind of pushes back into the system, and then we're going to have a rift zone eruption that continues afterwards. So first, the summit, and then possibly some years down the line, the rift zone should be reactivated again as well. If we're on to any kind of, truth at all. It's hard to know that, absolutely, but this is basically the best guess we got right now. And I think maybe I kind of went off in the weeds here, Dan, a little bit.
Well, let's see how everyone's doing. If hopefully you're following, Phil has pieced together a pattern here with some historical analysis that, there's a relationship between the erupting of the rift and the collapsing of the crater. And it looks like during high flow times, we have this kind of alternation between the rift erupting a lot of lava, then collapsing, exploding once maybe while it recharges before rift erupting again. And so that's important because it's starting to give us a window on maybe where we're at in the history of the behavior of this volcano. And in a way, Phil's telling you the summit might explode as a result of what's already happened here. And so that's serious, but he's also explaining, it might be a one-time only sort of thing as the volcano recharges after all of this. And so these are things that can help us give insight as to where we're at now, that can help us think about what's could be happening next, yeah? And so Phil and I are in agreement here that we both think probably the volcano still is having a high amount of recharge is coming into the volcano. Hasn't changed dramatically from what we've been seeing, which is continuous effusion of lava. So there's probably still lava recharging it. The question is it done erupting in the rift now? Is it gonna go to the summit next? And so that starts to point to a few different scenarios. And so Phil's already mentioned this before, if the summit is next, we want it to erupt sooner rather than later, because the longer there's a pause, we get groundwater intrusion, and that can lead to this explosive activity. If it erupts sooner at the summit, there won't be time for groundwater to intrude, and most likely we'd see lava erupting down in that deep crater. And we've discussed this before, like when you think about it, that might be our best possible choice, is if the lava returns to the summit soon, because it is still recharging. We think it's probably recharging at the rate that it did before. It'll get back to erupting at the summit soon, and we could enter a period where we see beautiful gushing lava down in the crater inside the national park where it can't hurt anyone, and we can all go and take a look, and that would be a way better scenario. But you can't underestimate what the volcano is capable of. And so understanding this history, the relationship between explosive activity and these large collapses and eruptions out of the rift, this is telling us maybe something about where we're at now. So there's a chance in the future we might have to get through an explosion at the summit in our lifetime. The better option is actually if it stops erupting out of the rift. That's the first thing I'm looking for. Be sure it's not going to erupt in the lower rift. And then if it erupts lava in the summit, that could end up being the beautiful lava viewing that we've all hoped for, a once in a lifetime thing to see a lava lake in the bottom of the new crater. So hopefully some of this discussion about the inner workings, the history, you can glean some understanding. There is a cause and effect to these things, but we have so many unknowns that, you know, Phil is offering a really great breakdown of what the history does and doesn't reveal about this pattern of explosions at the summit. So things to think about. Maybe I should leave it at that.
Yeah, I mean, yes, I mean, it's definitely pointing out a pattern. A pattern, to me, usually goes, you have your high supply. Your high supply first fills a summit crater, if it's there, right? And if it's been sitting there for a while, it's going to explode when it comes through the water. It's got to build some kind of lid for itself to inject into the rift zone. Now, I don't think it's an exclusive thing. You could actually have some rift zone stuff happening at the same time as the summit. But
wouldn't that be great? Oh, great.
But I would say that you probably can't have a long-lasting, sustained, high-volume rift eruption unless you close the summit off first, right? So if something does, you know, by this way of thinking, even if activity continues at the fissure, it's not going to be anything like it happened before, and it may not even be anything like Pu'u'o happened. In fact, it might even be something less than that, because some of that supply, when Pu'u'o was coming in,
was recharging the summit.
And not as much, and now you're going to have more of that to actually recharging the summit than before. So you'd have, in my mind, something, it could go in that kind of scale, but it's going to be a lot less lava coming out, you know, in that scale of how long it might actually take to wane and kind of fiddle out, how long we might see glow in air, might see spatter for a while, you know, I mean, I can't discount it, but it could do that for years, you know, I can't. I think it's not likely personally, just my gut belief, but you know, if that thing is really open all the way and there isn't that big a constriction between Pu'u'o and it's open essentially all the way to the summit and there's nothing actually blocking it and most of the flow is still going up, some can still get sideways a little bit through there, and maybe you could sustain something longer term. So it's not necessarily either or, but the focus definitely goes to the, you know, like the hazard on the rift zone is decreasing and the hazard at the summit is increasing, right? And so that's all it is, a pattern, right? So normally you have, you know, the summit filling, you have some kind of lava lake filling that hole, then you can sustain a long-lasting rift eruption. And maybe at that point, you have so much pressure that you can induce one of these large caldera collapsing eruptions like we had this year.
Yeah, but there's a glitch, because so far, the inflation is in the rift, not the summit. So if it's a race between the rift and the summit right now, the rift has more signs of activity than the summit. If you
believe that the rift sign is actually a sign, and that's where maybe 20 minutes ago, 30 minutes ago, we talked about how I don't see it's big enough yet to eliminate noise as something is happening there. Yes, I agree. If we see a definite signal in a rift,
maybe in retrospect we'll be like, oh yes, that was all important.
We may well see like, oh yeah, that definitely was a rift signal, but we also may be like, oh no, it's not doing anything like that, and we just don't know what it was, or if it did it didn't matter, or you see what I'm saying? So it's, you know, we still don't know. We still don't know. But basically, if it, you know, to cause this kind of summit collapse, you have to have had basically the summit not collapsed, all the way refilled, and sustain a rift zone eruption for a while to then build enough pressure to inject a big blade and have a big rift zone eruption that causes a collapse that follows. And it's really hazy for 1790 in particular because we don't know the order of the eruption in the rift zone compared to the explosion at the summit compared to the collapse of the caldera. Right? I'm proposing that the order would follow this year's pattern, where you have rift zone eruption and caldera collapse happening simultaneously in a way. Rift zone kind of starting things off, inducing a collapse, which then kind of catches up to it. Then a gap in time, like we're seeing now. And then when lava comes back in, enough time has passed for water to get in there to allow an explosion to happen. In the case of 1793 days of explosions, we don't know how long that was. We don't have any resolution, from the stories that Ellis recorded of like exactly what month of the year was this before that. We just don't know.
Yeah.
At least right now we don't know from what we've been able to read.
Yeah.
So I don't see any reason to discount that pattern as being present in 1790 being the same one we see again today. And kind of continuing the story in 1790, after those explosions, there were fountains from the ring cracks of the collapse, right? And then a lava lake that came into place, less than 20 years later.
The fountains are before the ash, right? The scoria is under the ash.
There's both.
The reticula under the
yeah,
ash.
so we can maybe look at the actual cross section of the. But there's a layer that it's called the golden pumice that occurs only on a rim of the crater. We believe that the fountain had to have been from within a collapse pit, right?
Okay.
So anyways, we can look in more detail that as
things.
well, looking at the actual stratigraphy of the area. But, once lava comes back through and explodes through the wall, because unless you have your explosion first, where's the lava to cause a fountain, right? So in my mind, you have to have your explosion first, the magma's going to come in, open that pathway, so you basically burn your hole through the water table. Then a magma that's coming in is going to find those cracks, and then you're going to have your fountains, probably briefly, because if there's that much magma coming through there, it's going to start ponding and make a lake sooner than later. And, we don't know what happened between 1790 and 1823 exactly, but by 1823, the lava lake was well established and had refilled all that collapse pit that wasn't even there anymore.
Yeah.
Right?
I appreciate the analysis. I still think that there's ways that it could veer in a different direction. So
oh, totally. I'm not saying this is...
We're definitely in the waiting period. I think it's definitely valid for considering what could be happening at the summit. And I think it would be better if it was just lava and not explosions. And in order for that to happen, it needs to return to the summit sooner rather than later.
Yeah.
The longer it pauses to return to the summit, it increases the likelihood of explosion.
Yeah.
And so that's definitely a way to frame the discussion there. There's a time frame for what scenario becomes more likely. And so
and it's really tricky to tell that geologically, right? Because geologically, we're using ash deposits as indications of collapses forming, collapses and following eruptions through the caldera. If we don't have an explosion, we don't have a geologic record of that event, right? So if you have, like some situation we're proposing, lava comes back soon enough that it doesn't explode and just starts puddling in the bottom, unless you get a pumice that happens to shoot out of the crater, it's all going to fall in that hole and all get buried in the ground, and you're not going to see any of it ever.
Yeah.
Until you have a giant collapse again, and maybe you have some exposed walls, right? We kind of touched on that briefly earlier today, right?
And that's the amazing thing. And so, we can barely scratch the surface in these diagrams and in the historical analysis of the lava flow, but now there's something new, and that's that the crater has collapsed and dissected through 1,000 years or more of geologic evidence in the crater. So for the experts to look inside the collapsed crater at Halemaumau now, they can get all sorts of new detail about the deeper history of the volcano. So it's an amazing, amazing thing to see the crater so deeply collapsed to expose those rock layers, and that can give more clues and more answers about these scenarios as they have time to research it. But the bottom line is we do know there is this pattern with the explosions at the summit. So...
But we know a little bit about it.
A little bit, yeah.
We basically know 1790, kind of.
Yeah.
And we don't have much resolution between there and 1500.
No.
And that's, I'd put out that, unless you have some you probably have somewhere some weird part of the crater which is older than the 1500 collapse. But most of it's going to be filled from 1500 till now, I would imagine. So at least from that period of time, we should have a much better resolution looking forward. As soon as we get some geologists to rappel down in there, or some drones to go collect some rock samples or that kind of thing, you know.
Might be drones first. I don't know if geologists are going to be going in there very quickly. Some of them would.
I bet there's some that are just itching.
They would love
right now.
to, but I don't know if they'll let them.
They don't even let tourists go to the edge of the crater to look in at this point. So, you know, it's going to be a while before any geologists are allowed in there.
It's amazing, though. Amazing.
So that's where we stand today.
Yeah, that's a good walkthrough discussion. Hopefully it represents a little bit about the scale of these different ideas, where they're happening compared to us here on the surface, and gives some things to think about. As little as we know, we do know a little about what the volcano is capable of, and we should never underestimate it. And we'll continue to look for signs of what type of activity and where it might be happening next. But something will develop out of this.
Flashed orange.
Flashed orange. Oh.
Yeah. Yeah. Oh my. I think we mostly had a good signal. Had a couple little hiccups here, but mostly for the most time. Cool. So yeah. So Arthur just asked us a question and asked us over the fact and we were asking in person. There's Arthur.
Online when he's sitting here.
So yeah, we'd love to look at some of those images of the crater walls and do some more detailed analysis. I think so far the images that we have, you know, we haven't really gone into that detail and looked at those angles, but that's something that I'm sure that some geologists in HVO is probably drooling over right now, looking at that information. So we'll see what we can find out for you guys. You know, it'll definitely help when in about a little over a week we actually can go in there and see with our own eyes.
Wow!
Because you know it's just not the same with the photographs. So we'll look forward to that. And as far as tomorrow, I'll be down at the hub in the afternoon, doing our usual.
Yep.
And
I'll be there too. Come talk to us.
Yeah. And there is a rumor that there might be some music tomorrow night. We'll see if that's true or not.
Right on.
We don't know exactly everything that's going down there. But that's our update for today. So, you know, as we stand, we're still waiting for information that tells us anything about the fissure doing anything differently. Or
waiting for the
rains. Rift zone.
Waiting for the rains to disappear from our tilt signals so we can make a better judgment about what's real and what isn't.
Yeah, at the same time, kind of laying out some options, you know, of what might possibly be happening underground. You know, I don't think that we presented like a unique solution. You know, I just think we presented one that does actually account for all the information that we know right now. So, and there are not many of those that kind of put all of it together, you know, so, you know, even if we're wrong, it's our first stab at it. You know, that's how we work in science, is with a initial model, and you refine it, you iterate back and forth. Oh, we got to change this, change that, you know, so we'll all go through that journey together with you guys.
Even if predictions tend to be off on some level or another, if they're not exactly right, the predicting and guessing and interpreting as we go along is leading us into better understanding of what actually is happening. So if predictions are off, we'll be able to look back and learn something from why our predictions were off. But we're trying to share information that's understood about the pattern of the history of the volcano. So be aware.
At least we think we understand it. We're not quite sure all the time.
We understand some things. Maybe.
So, all right, you guys. We'll leave the rest until further discussion, yeah?
Yep.
Until then,
stay
classy.
classy.